Welcome to this Trend Guards Explainer. Today, we're cutting through the internet hype to look at the cold, hard, verified facts behind what everyone's calling the ChatGPT moment for robotics. We're going to completely separate the reality of humanoid robots from those staged demo reels you see online, and we'll analyze exactly how physical AI is literally rewriting the rules of global labor. All right, let's jump right in.
To really grasp the magnitude of this shift, we have to recognize a massive confirmed fact. The 40-year era of hand-coded, brittle robotics, it just officially ended. You see, for decades, pretty much every robot on Earth was locked inside a factory cage, just replaying precise, hard-coded instructions. If you changed a task by even a fraction, you had to rewrite the whole code. But now, because AI foundation models have essentially been given a body, machines can look at a completely novel situation, like, say, a table covered in unfamiliar objects, and just figure it out without being explicitly programmed for it. It's a total game changer.
The absolute core of this breakthrough is the Vision Language Action, or VLA model. Just as large language models generalize text, VLAs process physical patterns. Based on documented engineering architectures, these models take in visual input through cameras, understand plain English instructions like, hey, clean up this table, and then directly output physical motor commands to the robot's limbs. For example, according to official technical releases, Figure AI built their own in-house VLA called Helix, specifically to power this exact kind of autonomous reasoning on their robots. The paradigm shift here is stark. Old robots were incredibly brittle. They replayed instructions and completely failed if a part moved even 2 inches to the left. New robots, though, they pursue goals, they generalize, they adapt, and they actually understand the physics of the world around them. And crucially, this intelligence breakthrough is arriving at the exact same moment that physical hardware, things like electric actuators, tiny sensors, and high-capacity batteries, has become surprisingly cheap and capable. So the brain and the body are finally arriving together. Based on official deployments, we're seeing a really clear divide across a few categories. First, we've got the brain-first startups. Think Figure with its Helix model, 1X, Apptronik, and Agility Robotics, whose Digit robot is actually already deployed and doing verifiable tote-moving work in real-world warehouses today. Then you've got the giants betting on massive manufacturing scale like Tesla's Optimus and Hyundai's now all-electric Boston Dynamics Atlas. Next up is the infrastructure layer, heavily dominated by NVIDIA. And finally, the global hardware players, highlighted by China's Unitree, which is aggressively undercutting the market with some shockingly cheap, mass-produced hardware. Now, we absolutely cannot overlook NVIDIA's strategic position here. CEO Jensen Huang officially stated on the record that physical AI is the next wave after generative AI. And NVIDIA? Well, they're effectively supplying the picks and shovels for this entire economy. According to their verified product roadmaps, they're providing the GR00T foundation model, the Isaac and Omniverse simulation tools to train robots in virtual worlds, and the Jetson Thor onboard computers to run the AI physically inside the machines. Basically, whoever wins this robot race, they'll almost certainly be running on NVIDIA silicon. According to documented engineering workflows, robots learn through 3 primary, verifiable methods. Step 1 is video learning. This is where models ingest massive amounts of video to build a basic intuition of physics, like understanding that objects fall down or doors push open. Step 2 is simulation. Using platforms like NVIDIA Omniverse, a virtual robot practices a task literally millions of times at software speed before it ever even touches the real world. And step 3 is teleoperation. That's where humans physically drive a robot through a real-world task using sensors. It creates highly valuable but incredibly expensive demonstration data. But here's the massive hurdle right now: data. Unlike large language models that just trained on the entire text of the internet for free, robots have no internet of physical action to pull from. Every single real-world demonstration has to be painstakingly captured. Plus, engineers have to overcome what's known in the industry as the sim-to-real gap. That's where a perfectly trained software policy completely fails in the noisy, friction-filled reality of the physical world. The verified consensus across the board is that whoever solves this data bottleneck is going to win the robot economy. Reporting purely on the documented superpower dynamic and supply chain data, we're seeing a very clear split in capabilities. The US is currently leading on intelligence and compute, owning the foundation models, the NVIDIA chips, and the simulation software. Basically, they own the brain. Conversely, China is leveraging its massive, established robotic supply chain to totally dominate the physical hardware. They're producing cheap motors, actuators, and batteries at breakneck speed. That's the body. Right now, each side is attempting to control the choke point it owns in order to dominate the global platform. And the reason governments and corporate giants are aggressively funding this whole thing? Well, it's perfectly represented by this number. According to global demographic and economic data, we are facing a $1 trillion global labor shortage in warehouses, logistics, and factories. This is driven by verifiable trends, like aging populations and shrinking birth rates across major economies. So, this isn't just about selling cool gadgets. It is a fundamental race for absolute productive capacity.
Based on recent hardware benchmarks, when assessing any new robot announcement, you've got to look for these 3 verified hurdles. First up, battery energy density. Current platforms often only have a few hours of active life, but a true commercial worker, it needs to last a full shift. Second is hand dexterity. Building a hand that can grasp an egg without crushing it, or reliably turn a wrench, is brutally hard. That is exactly why many of those viral demos quietly avoid fine manipulation. And third, safety. A 60-kilogram autonomous machine moving around humans faces immense, documented regulatory and physical safety bars.
The absolute most crucial engineering metric to remember here is 99.9%. See an 80% success rate on a task? That makes for a fantastic viral video on social media. But a deployed commercial product requires 99.9% reliability, day in and day out for years. Driving down the unit cost while pushing reliability up to that commercial standard is exactly where the true engineering war is being fought today, far away from the marketing cameras. The realistic near-term story is not total job replacement tomorrow. According to logistics industry forecasts, humanoids will first be deployed to fill dull, dirty, and dangerous labor gaps in highly controlled environments like warehouses and factories. These are tasks that sectors already desperately struggle to fill. So what this means for human labor is a transition. Human value will shift upward. The premium will move away from doing the rote physical execution and toward judging, directing, exception handling, and orchestrating massive fleets of these machines. The ChatGPT moment for robotics is a verified reality. The intelligence breakthrough is undeniably here. But we're still in the early GPT-2 era of physical AI. True, flawless ubiquity is still being built. So knowing the geopolitical stakes, the documented data hurdles, and the stringent safety requirements we just covered, I want to leave you with this. Would you trust one of these fully autonomous machines operating in your home right now? Let us know your thoughts. I'll see you in the next briefing.
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.